All right, so this says the table below shows the number of individuals infected with the disease T days after it's first detected by the CDC. So we're just simply going to put this information into our stat list on our calculator. So I'll turn that on. I'm going to go to stat right in the middle there. I'm going to hit enter on the edit option. If you have something in here, which you probably will, you're going to go up and actually highlight the L1 and L2 and hit clear enter. If you forget these instructions, they are in the textbook, right in this section, and they're in the lecture videos. I'm going to put the days into L1 and the infected individuals into L2. Okay. So now it says for each of the following problems, enter the regression equation values with at least 3 decimal places and enter predictions to the nearest whole individual. So this says find the exponential regression. So once I have everything in the list, I'm going to go back to stat, and now I'm going to calculate something based on my list. And I'm going to scroll down until I see exponential regression, which is option 0. X values are coming from L1, Y values are coming from L2. I'm going to hit calculate. So my equation is going to be Y equals 688.696 times 1.0595 or 1.06 to the D. So that'll just, you'll put these numbers in right here. Use the model to predict the number of individuals infected after 15 days. So I'll just replace T with 15. So I have 688.696 times 1.06 to the 15. So I get 1650.5 or 1651. Okay, you're going to do the same thing for each of these, except now we're looking for the linear regression. So I'm going to go to stat. The data stays the same. I'm going to go to calculate, and I'm going to do option 4, linear regression. That'll give you your equation here, and then you can use that to find this answer. And then lastly, the quadratic regression, that's just going to be option 5. That'll give you 3 numbers, A, B, and C. And you'll use that equation to find this value. 4 is a dumb question because we don't have a way of telling which is the best, but your answer is going to be quadratic. All right. The second one you sent me says, what is the domain of this function? It's not written here, but there should be arrows on the ends here. So our function is going forever to the left and forever to the right. So it's going forever to the left. That's going to be negative infinity. To input infinity, you're just going to do double 0 like that, double lowercase o. And this will be positive infinity. What is the range? Well, how far down does it go? It goes down as low as -1. So it's going to start at -1, and it's going up forever, so it's going to go up to infinity. It actually hits -1. So this is going to have a bracket, and the infinities always have a parentheses. So this will look like this, from A to B, like that. Where is it increasing? Well, it's at its minimum here. So everywhere to the right of this value, it's increasing. Everywhere after x equals 1 up to infinity. So this will be from 1 to infinity. And it's kind of weird. I don't know what their answer would be, but technically, since it's not increasing at 1, it's horizontal at 1. So this is going to be like this, A to B. I just want to check to make sure they have the same thing that we do. Yep. Okay, good. And on what interval is f of x less than or equal to 0? That's where is it negative? Well, that's from here to here, from 0 to 2. We can't include 0 and 2 because, oh yeah, we can, because it's less than or equal to. So this is going to be bracket. Oh, I'm sorry, there should be A's and B's. From 0 to 2.